guys, so this is your review for sections 9.5 to 9.8. This covers completing the square, it covers finding the vertex, it also covers choosing the right module, it also covers using quadratic formula, and also, oh, there's one last one in there too, I can't quite remember which it is. Standards that are in here, you can go through and take a look at all of those. If you want to pause it, I'll kind of get my little white area out of the way up there. So the first thing that you're going to need to make sure that you know how to do is to complete the square. And if you don't know how to do that, you should remember that the most important formula you should have written down in your notes somewhere is that you take, let's go for a marker that actually works. So you're going to take your b term, divide it by 2, and square it. And that will give you the number that you need to add to both sides. I'll kind of leave that up there. It does say b squared, or b divided by 2 squared. So when we're looking at this first equation here, you'll notice it's a 4x squared minus 8x equals 24. So when we're looking at this, we should take note that the trinomial is not easily factorable. And so we want to come up with a better way of solving it than we normally would. So in this case, what we can do is we can create a perfect square. And you'll remember perfect square trinomials, right, multiply this way. Or this can be kind of any number that's in there. But they're in this form where it's one unit, one binomial times itself, or squared. So when we're looking to do this, our trick here is to take this middle unit and divide it by 2 and then square it. So I'm going to go ahead and take negative 8, divide it by 2, which will give me negative 4. This is an important number, and then I'm going to take that number and square it. Negative 4 times negative 4 is positive 16. So as we're going through now, 16 is the number that I want to add to both sides of the equation. So I'm going to move over here to the side. I'm going to take my 4x squared minus 8x equals 24. Make sure that your c term is on the opposite side of the equal sign from the rest of your a and b terms. After you do that, you're going to take that 16 and add to both sides of that equation. So in this case, we'll have 4x squared minus 8x plus 16 equals 24 plus 16 should give us 40. And then once we've done that, we want to factor this side. Remember, this is a perfect square trinomial, so it should factor into this form. And we know that to get our 4x squared in the front, we're going to need a 2x. And then to get our positive 16 on the end, we're going to need a 4. But remember, when we made that perfect square, we used a negative 4. And that's so that we can get that negative 8x in the middle. So we need a 2x minus 4 quantity squared. And that's equal to the number 40. Now in order to solve from here, you guys know the rest of the way out is just solving equations. So to get rid of that squared, we're going to take the square root of both sides. So that'll give me 2x minus 4 equals positive negative square root of 40. Now sometimes you leave the square root of 40 in as a radical. Other times you're going to want to go ahead and take it and make it a square root. In this case, we're going to go ahead and estimate it. So I'm going to take 40, put it into my calculator, and then take the square root of 40 and round it. And that gives me 2x minus 4 equals positive or negative. And this is actually an approximately equal to, because I'm rounding it. 6.324 is my next number, so I'm just going to leave it at 6.32. I'm going to split this into a positive and a negative side. So 2x minus 4 is approximately equal to positive 6.32, and 2x minus 4 is approximately equal to negative 6.32. So I'm going through there to solve now. I'm going to add 4 to both sides. And then that gives me 2x equals 10.32. Then I'm going to divide by 2. I'll end up with x equals approximately 5.16. One side divide both sides by 2. I'm going to do the same on this side, add 4 to both sides, and that'll give me 2x is approximately equal to negative 2.32. Divide both sides by 2, I end up with x is approximately equal to negative 1.16. So in this particular equation, my two possible solutions are either x equals 5.16 or x equals negative 1.16. And that is our factor for that by completing the square. Great, guys, so we're going to start off on the next one, and this is looking for the vertex of your parabola by completing the square. And if you remember from your notes, if you can arrange the equation to be in the form y equals x minus h quantity squared plus k, then you'll be able to pull k and h as the vertex points. So it makes it a nice way of quickly being able to go through and find the vertex. So our problem starts off with x squared minus 10x equals 20 plus y. So in order to do that, you can see it's not really easily factorable. So I want to be able to make a perfect square on the other side, so I need to complete my square here. So on this side, what I'm going to want to do is I'm going to want to take this and find what number I could add to both sides to be able to factor this to a perfect square, or to a binomial squared. So when we're looking here, we use that same formula of b over 2 squared. So my b is going to be negative 10, so that's negative 10 over 2 squared. That gives me negative 5, which is important. That's the part that I'm going to need in my binomial squared, which is 25. So I'm going to add 25 to both sides of the equation. And in doing so, I'm going to get x squared minus 10x plus 25 equals, if you notice here on these two, oops, I apologize, that's supposed to read negative 20. So on these two, oh goodness, I typed it wrong on the slide. Sorry about that. So it should read negative 20. So this should in the end come back to 5 plus y on the other side. So remember again, I'm looking for that formula of y equals x minus h squared plus k. And if we get that, then I know that my vertex point is at h and k. So we're super close to being in this format. This trinomial on this side, we know will factor out to a perfect square. So the square root of 25 is 5. I've got a negative 10 in the middle, so I know that has to be a minus 5. And that's going to be equal to 5 plus y. And then notice here in my format, I need y by itself. So I'm going to go ahead and subtract 5 from both sides. And I'll get x minus 5 squared minus 5 equals y. And now I'm in this format here. So you can see that 5, not negative 5, because remember your format is x minus h. So 5 is my first half of my vertex point. That's the x coordinate. And then whatever my plus k is on this side, which in this case is a minus 5, is my y value. So I can go ahead now to find the vertex, and I know that it's at 5, negative 5. And that's where the vertex of this parabola is located. Make sure that you have this written in your notes. It's a very important piece of being able to work through this chapter. So the next one is probably the easiest way. You should be able to use your quadratic formula to solve any quadratic equation. Any equation can be solved with your quadratic formula. So anytime you have a quadratic, if you don't feel like completing the square, if you don't feel like factoring or any of the other methods you've been taught, you can go ahead and use the quadratic formula and it will solve your equation for you. Also, if you don't like to have to work out the math longhand, there's a number of quadratic solvers that you can download on your calculator, or you can also find one online. You can also download them if you have a smartphone. So you should have written down in your notes or memorized the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. In this case, we want to start with our quadratic equation, which, as you can see on the slide, is 2x squared minus 3x equals 20. Remember, this must be written in the format ax squared plus bx plus c equals 0. So I need to go ahead and make this equal to 0, so I'm going to subtract 20 on both sides. And by subtracting 20, I will get a perfect setup from using the quadratic formula. Remember, this is a, it's going to be 2, my b is going to be negative 3, and then my c is going to equal negative 20. And don't worry about that c equaling negative 20. Sometimes that freaks people out, that the number is going to be kind of big. Don't worry about it. It'll all work out in the end. So I'm going to go ahead and plug those 3 in here and solve. So I have negative 3 plus or minus the square root negative 3 squared minus 4 times 2 times negative 20. And all of that is over 2 times negative 3. So now I have lots of math and number crunching to go here. I'm going to take my negatives and cancel them out first, which gives me 3 plus or minus the square root of negative 3 squared, which is 9, minus 4 times 2 times negative 20. So remember, these are all multiplied, so I can do them in any order. So negative 4 times 2 is negative 8, times negative 20 is negative 100 and, positive 160. Then on the bottom, I have 2 times negative 3, which is negative 6 in the denominator. So now I'm going to split this, or I actually could probably do the math a little bit more here. So I've got 160 plus 9. That actually will give me 169. I'll save a little space there. So now I've got 3 plus or minus the square root of 169 over negative 6. So as we work this through, I'm going to split it into 2 parts. So I've got hopefully just enough space here on the bottom. 3 plus the square root of 169 is 13 over negative 6. And then 3 minus the square root of of 169 is 13 over negative 6. So in solving those two, that gives me 16 over negative 6. Oh, excuse me, I made a mistake all the way back up here. Is that not terrible? This should have been over 2a. So mistakes happen. We just go ahead and fix them right up there. I hope that as I was going through, a number of you guys were probably like, no, Dawn, you messed up. You made a mistake. You put in a 3 instead of a 2. How about that? Does that look a lot better now? So I accidentally, in the denominator, put in a 2 instead of, put in a negative 3 instead of a 2. So I just fixed that. That changes my denominator from negative 6 to 4. So as I'm solving that now, I'll kind of write it over here on the side. 3 plus 13 over 4 is 1, and 3 minus 13 over 4. That's my positive and my negative side. That gives me 16 over 4, which is 4 for one answer. And then my other answer is negative 10 over 4, which is negative 2.5. So my two possible answers here for this one, my two setups for the answer are 4 and negative 2.5. I wanted to show you guys another quick way of checking this. Going through and using your quadratic formula to solve is very important to be able to do, but you can also double check your answer by Googling a quad solver, quadratic formula solver, and you can choose just about any quad solver that's out there. And all that you need to do then is to go in and put in your A, B, and C values. So I'm going to put in my A, remember, was 2, my B value was negative 3, and my C value was negative 20. And when I do that, you'll notice first it graphs my equation, and it shows me that my roots for this parabola are at 4 and negative 2.5, which are exactly the two numbers I came up with, so I know that I'm right. Part of the quadratic formula is also very important to us. It's called the discriminant. And it's this section that's here underneath the square root symbol. This can tell us how many solutions there are for our problem. So when we're looking at this, if we take the discriminant, which is b squared minus 4ac, and that number is greater than 0, which means that it's a positive number, that equation will have two real solutions. If we take that b squared minus 4ac and we get exactly 0, then that has only one real solution. And then lastly, if we take that b squared minus 4ac and it's less than 0, come on camera, that's less than 0, then we'll get no real solutions. And what this means graphically is that that parabola lies above the x axis. So let's take a look at the one that we have up there on the slide. It gives us 2x squared minus 3x equals 20. And then in this case, we want to go ahead and move the 20 over so that it's equal to 0. So 2x squared minus 3x minus 20. And that's equal to 0. And then we'll identify our a, our b, and our c values. A is 2, b is negative 3, c is negative 20. Then we plug those in to our discriminant, which is b squared minus 4ac. And that should be able to tell you, based on its value, on how many solutions there are. So my b is negative 3 squared minus 4 times 2 times negative 20. So this will give me 9 minus 4 times 2 is 8 again, times negative 20. So that's negative 8 times negative 20, which will be negative 160. Or excuse me, positive 160, because we have a negative times a negative. And so that means that my discriminant now is 169. This is a positive value, so that means that it sets here in our first equation, our first setup, which means it's greater than 0, so I have two real solutions. So that tells us how many solutions we have by using the discriminant. Let's use that discriminant and we'll solve one more equation to see how many solutions it has. So in this one off the slide, we've got x squared plus 3 equals 2x. And so we need to set that equal to 0. So I'm going to move the 2x over. So x squared minus 2x plus 3 equals 0. And in doing that, now I can identify my a, my b, and my c values. So my a value is 1, my b value is negative 2, and my c value is 3. So I'll plug those into my discriminant. I've got b squared minus 4ac. So that gives me negative 2 squared minus 4 times 1 times 3. And then that's negative 2 squared is 4, minus 4 times 1 times 3 is 12. 4 minus 12 is negative 8. So when we look back over this, my discriminant was not positive, it was negative. It was not equal to 0. So over here it was less than 0 or a negative number, which means there are no real solutions for this equation. So if we graphed this, the parabola would sit above the x-axis.